Now we know the sum and difference formulas for sine, sum and difference formulas for cosine, sum and difference formulas for tangent. But let's focus on the sum formula only at this moment. Just the sum formula for sine, sum formula for cosine, sum formula for tangent. Forget about the difference. So in this case, if we just consider the sum when alpha happens to be the same as beta, and we get a special formula. That is because when in general, alpha, beta, they do not have to be the same, but they can be the same or different. So if beta and alpha are the same, suppose we have alpha, alpha, then the formula will change, right? The beta is also alpha when beta equals alpha. So you see, I will change. That becomes a special formula. This special formula is called double angle formula. So we have three of them. So we can see the left-hand side of the first will become sine 2 alpha, because alpha plus alpha, right? Sine 2 alpha equals, this is a sine alpha cosine alpha plus cosine alpha sine alpha, which is the same. So twice of the sine alpha cosine alpha. You see, sine alpha cosine alpha. Here, cosine alpha times sine alpha is still the same as sine alpha cosine. So that's twice of this term. We get double angle formula for sine. How about second? So the second formula is becoming a double angle formula for cosine. So the cosine 2 alpha equals, you see this cosine times cosine alpha, so cosine square alpha minus sine alpha times sine alpha is sine square alpha. And then we can also get double angle formula for tangent. Tangent 2 alpha, which is, you see, numerator will become tangent alpha plus tangent alpha, which is twice of the tangent alpha. And then 1 minus tangent alpha times tangent alpha is tangent square alpha. So we have a double angle formula for tangent as well. So now we have 3 double angle formulas. Yeah, just simply from this, it's a special case when beta equals alpha, then we get a double angle. So now we have, yeah, you see when alpha equals beta, that's a very special case. Then we get double angle formula for sine. When alpha equals beta, we get a double angle formula for cosine. And then double angle formula for tangent. So with these double angle formulas, let's see a clean version. After we get a nice result, we know when we see a situation like this, we can also apply this, right? Special additions formulas for double angles. So we have 3 formulas. Yeah, sine, cosine, tangent for double angles. And let's look at this cosine. Cosine 2 alpha can be written as cosine square alpha minus sine square alpha. However, we know sine cosine are related by this identity, by this Pythagorean identity, right? That means, yeah, the sum of the squares of sine cosine is 1. So let's assume I want to write this expression in terms of sine only. So then I can replace the cosine. I can replace this cosine with 1 minus sine square alpha. That way, cosine is written in terms of sine. And the sine, the other term is still there, right? The minus sine square alpha. So the overall expression becomes 1 minus sine square alpha minus another one. So that's 1 minus twice of the sine square alpha. So that means the double angle formula for the cosine can be also written in terms of sine function only. Yeah, so let's put, instead of this, we can also write, because cosine square alpha can be replaced with 1 minus sine square, right? So with the other one, so we'll have 1 minus twice sine square alpha. So that's another way to calculate cosine 2 alpha, cosine 2 alpha in terms of sine alpha only. So what if I want to write this in terms of cosine alpha only? In that case, you will have to replace sine. So then let's think of this formula. If I want to keep the cosine alpha, I want to replace the sine alpha, right? So the sine square is equal to 1 minus cosine square alpha. So this time we replace the sine square with 1 minus cosine square alpha. So the overall, this quantity becomes an expression involving cosine alpha only. Then we continue to reduce it. So you see, we remove the parentheses. Minus 1 minus negative becomes plus cosine square alpha. So we have twice the cosine square alpha. So there's a negative 1 here. So we, you see, right, these two combined. So we have combined like terms. And then the answer is now in terms of cosine alpha only. So we can write this in terms of cosine alpha only. Okay, that will be twice of the cosine square alpha minus 1. So for this double angle formula for cosine, we have 3 versions. Let's look at 3 versions. So in addition to that version directly got from the sum formula for cosine, right? When the two angles are equal, we have immediately that version, cosine square alpha minus sine square alpha. So that is one version for this cosine 2 alpha. But this version can be converted into a new version. That is, if I replace the cosine square in terms of sine, so you see cosine in terms of sine, then this formula will become this. So it is equal to this. twice, 1 minus twice the sine square alpha. That is, if I represent this expression in terms of sine alpha only. But it's also possible to express this expression using cosine alpha only. That means you replace the sine square alpha. So the sine square alpha, so this same expression, if I want to using cosine alpha, so that is to replace sine square alpha with this 1 minus cosine square alpha. Then we remove the parentheses. So minus 1 minus negative, which is plus cosine square. Then we get a different version. So 3 different versions. Let's see them in one place. Double angle formula for cosine 2 alpha is cosine square alpha minus sine square alpha. Or in terms of cosine alpha only, it will be twice of the cosine square alpha minus 1. Or in terms of sine alpha only, it is 1 minus twice of sine square alpha. So that means they are all the same. So because they're all equal to cosine 2 alpha, right? So we have 3 different versions for cosine 2 alpha. So let's use these double angle formulas and assume we have cosine value for a certain alpha, which is in quadrant 4, fourth quadrant. So this alpha is in fourth quadrant and cosine is positive. We know that. So this alpha has a positive cosine value because alpha is in fourth quadrant. And we want to find sine 2 alpha, cosine 2 alpha, tangent 2 alpha. We want to find the sine of the double angle, right? We only know for this alpha, we know cosine. How do I find the sine of 2 alpha? Sine 2 alpha using the double angle formula, we know it is 2 times sine alpha cosine alpha. So that means if we want to find the sine of the double angle, we need to know the sine alpha cosine alpha, but we are only given the cosine alpha, not sine alpha. So how we need to look for the sine alpha. Okay, given cosine alpha, you can find sine alpha, right? Using the Pythagorean identity. So again, so just look for it using this identity. You see the cosine alpha is given. And this square plus sine alpha, this quantity squared, should be 1. Then we can solve this equation to find sine alpha. So first find this quantity, the squared. And then after you find that, you will find sine alpha by taking a square root. So sine, this quantity squared, is equal to what? 1 minus this number squared. 1 minus 12, 13 squared. Yeah, so then what is this number? It is 169, right? 169 minus 144 is a 25. So you can do this difference, right? Yeah, we just get this number. Then if a square of this quantity, right? Square is 25 over 169. What is this quantity? Must be square root of this number, which is 5 over 13, or negative square root, negative 5 over 13. So which one should be the sign value? For the fourth quadrant, the sign value is negative. So we must take the negative value. So it's a negative 5/13. So with that, we have found sine alpha, which is negative 5/13. Yeah, it's all because we know the position of alpha, then we can decide whether we take positive or negative, right? So once we get that, then we're ready to find, the sine of the 2 alpha. Sine 2 alpha is twice of sine alpha cosine alpha, and then cosine alpha is given, right? We know it is 12/13. Sine alpha is found using Pythagorean identity. We just found it. It's negative 5/13 and twice of these two quantities. And the answer will be 13 times 13 is 169. And the 2 times 5 is 10. 10 times 12, 120. And the product is negative because of the negative sign here. So that's the sine of 2 alpha. We got sine of the double angle. We found the exact value. So sine of 2 alpha, and then what is cosine 2 alpha? Cosine 2 alpha. Cosine 2 alpha, let's say, because if we just simply use the given value, for example, cosine, suppose we want to use as much as possible the given value, because the intermediate value we found, what if there's a mistake, right? So let's, so of course, your calculation can be totally correct. You're allowed to use the intermediate value. So let's say I still prefer to use the given value. Can I find cosine 2 alpha? Yes, we have one version. Remember, using only cosine alpha, I can find cosine 2 alpha. That formula is 2 times cosine square alpha minus 1. So now, what is the cosine alpha? So cosine alpha given 12/13. So 12/13. And this number squared. And then there's a 2 in the front. So we multiply it by 2 and then minus 1, right? That's exactly the formula. We follow the formula when alpha is its cosine value is given. So we just put twice of the cosine alpha squared and minus 1. We just get this number. So what is that number? Let's do some calculation. 12 squared is 144, 13 squared 169, and then after you square, you multiply it by 2. Okay, what is that? And still don't forget you minus 1, right? So that number is actually 288 over 169 minus 1, which is 169 over 169. So you can eventually get a fraction. So that's a 9 1 2 minus, that's 119 over 169. So we get 119 over 169. That is cosine of the double angle. double angle, cosine to alpha. Yeah, we only used cosine value, you see, given cosine value to find cosine of 2 alpha. Because we do have a version involving only cosine value, we can already get cosine 2 alpha. So that's our result for cosine 2 alpha. So we have found cosine 2 alpha, sine 2 alpha. Yeah, so cosine 2 alpha, sine 2 alpha. Now tangent to alpha. Tangent to alpha, if we use the, okay, so let's recall that tangent to alpha is 2 times tangent alpha, 1 minus tangent square alpha, right? We better know the tangent alpha. That means in order to use this formula, we need to know tangent alpha. But do we know? We don't know. We're given cosine alpha. And we found sine alpha already. It's possible to get tangent alpha, right? Just by quotient at quotient identity. Yes. So we can find it. Tangent alpha. You see what we have is we know already this. We know this cosine because it's given. And we use Pythagorean identity, we found sine of alpha because we can calculate to decide the sine value. Afterwards, we do a quotient. We can find tangent alpha by doing this quotient, sine over cosine. Sine is this fraction over cosine, which is the given value, 12 over 13. Now, what is this number? This is, you see, a fraction divide another fraction is the same as multiplying the reciprocal, 13 over 12, right? Reciprocal. Then we can cancel. We get negative 5 over 12. Negative 5 over 12, that's the tangent alpha. So remember that one, negative 5 over 12. So now ready to use it in the double angle identity for the tangent. See, this is a double angle identity for tangent. So all we need is to use the tangent alpha, which is negative 5 over 12. So just put negative 5 over 12 for the tangent alpha. So then we work with this formula. So it's twice of this tangent alpha, 1 minus this quantity, tangent alpha squared. And then we get a number, right? This number is looks maybe intimidating right now, but let's let's reduce it. So the numerator, it is twice of this. How do we get this number? This number, this 2 can be canceled with 12, right? It's a 6, actually. So then we get negative 5 over 6. Yeah, that is better than before, right? And then now 1 minus, let's do the square first. We have to. So the square of this then becomes a positive. So 25 over 144. So 1 minus this number, how do we do a subtraction? Let's just look at this denominator. The 1 is actually 144 over 144, right? That's 1. Minus 25 over 144. So when the two fractions, you see this 1 becomes a fraction, then you can do a subtraction because the two fractions have the common denominator. So you subtract 144 by 25. Yeah, so just subtract 25 from 144. Then what you get is this fraction. Keep the denominator and subtract the numerators. So that's the numerator. And that is now this difference. And the numerator is still negative 5/6. So we just continue to see, okay, this numerator divide by another fraction. So we just simply multiply the reciprocal of the denominator. So we flip it, and then we can see that, and 6 can be canceled. 6, because it divides 6, this is 12. And 4, right? 144 divided by 6, it is actually 24. 24 times 5, 120 over 119. So this product is 120 over 119 after we cancel the 6. And it's a negative. Yeah. So with final answer, we found the tangent to alpha. So we have used double angle identity for sine, cosine, and tangent in this problem. So remember, to use each formula, you have to see that in order to use this given cosine, that cosine alpha is not enough, right? We have to find sine alpha in order to use this formula. That's what we did. In order to use the cosine to alpha, it is possible because we're given cosine alpha. Yeah, we just choose one version for the double angle formula for cosine, because there is one version that involves the cosine alpha only. Yeah, it doesn't involve both sine and cosine. So yeah, this version possible. We can calculate the cosine to alpha using the given cosine alpha. The tangent to alpha, if we want to use the double angle identity, we need to know the tangent alpha. But since we have found the sine alpha, cosine alpha, we can possibly get the tangent alpha, right? So we can use this formula to get tangent to alpha. So step by step, we got our answers for the double angle. Yeah, 3 trigonometric function values for this double angle to alpha. Actually, since in this problem, we have, before we find this tangent to alpha, right? We already find sine to alpha and cosine to alpha. We can directly use the quotient identity, because sine to alpha over cosine to alpha will give tangent to alpha. That's the quotient identity. You see, for whatever this angle, yeah, sine of the angle over cosine of this angle is equal to tangent of this angle. So we can find tangent to alpha this way, because we already found sine to alpha and cosine to alpha, right? So in the previous steps, and we can use quotient. We don't have to use double angle identity at this stage. So you see, cosine to alpha, it's 119 over 169. Sine to alpha, sine to alpha, let's see. Yeah, it is negative 120 over 169. See that it's found already. Then we can simply do this using the quotient identity. And you just see the negative 120 over 169, divide that fraction, which is multiplying reciprocal. Okay, we cancel, we get final answer as negative 120 over 119. That is the tangent to alpha. Compare. This answer is the same, right? Is as the one found by the double angle approach, double angle identity. So negative 120, negative 120 over 119 is our result by the quotient identity. And using double angle identity, we got the same. So you have multiple options. So at certain step, you can choose whatever you feel comfortable to use. Okay, so double angle identity produce this one, and this quotient, if you find this already, you can use quotient identity, we find the same answer. Now, let's try to recognize the following expressions. I want to find the exact value of each expression. The first expression, if we call this 15 degree as a alpha, do you recognize this is 1 minus twice of the sine square alpha, right? Yeah, that is a double angle formula for cosine 2 alpha. You see, that is, so we are given the right-hand side of this formula. Here you see cosine alpha equals 1 minus twice of sine square alpha. So yeah, this is 1 minus twice of sine square. So this is the same as cosine of this double angle. So we can write as cosine twice of the 15 degrees, which is cosine 30 degrees. So we just applied the double angle identity for cosine. Cosine 30, what is cosine 30? Square root of 3 over 2. It's cosine 30. So we found the exact value of this first expression. So let's just see the first problem. First problem, we're given such an expression, we want to find its exact value. Of course, 15 degree, you don't know the exact value of sine 15, but if we use the double angle identity, twice of 15, right? That's cosine 30. So this is a double angle identity in that formula when alpha is 15, then twice of alpha is 30. So cosine 2 alpha. This is the formula for cosine 2 alpha when alpha is 15. That's a very specific case. So now we know this exact value, which is square root of 3 over 2. Now, next one, This looks like another formula, which is tangent 2 alpha. You see the alpha is pi over 12. So if we call this one alpha, and this is actually tangent 2 alpha. That is the formula for tangent 2 alpha. So again, this is just a specific case when alpha is pi over 12, right? Alpha is a pi over 12. So this given expression can be written as tangent 2 alpha. Alpha is pi over 12 because that's alpha, right? We can. So what is twice of pi over 12? That is tangent. After we cancel the 2 is pi over 6. So tangent pi over 6 is square root of 3 over 3. Okay. So we found the exact value of the given expression, which is square root of 3 over 3. And this problem, the second problem is to be able to recognize that this is simply that form, right? That's the right-hand side of this identity. The given expression is the right-hand side of the double angle identity for tangent. You see twice of a tangent value, tangent of certain alpha, but the alpha is pi over 12. You compare these two, right? Alpha is pi over 12. So then that means this is tangent 2 alpha, which is tangent twice of this alpha, pi over 12. So just this formula when alpha is pi over 12. But certainly this is the right-hand side. So once we recognize that, then the rest will be straightforward because the rest is just simply recognize this as tangent of this double angle. Then twice of this angle is simply pi over 6. That's a special angle. We know the exact value of. So tangent pi over 6 is this. We found it. A third question is sine 75, cosine 75. This one is very similar to the double angle formula, okay, sine 2 alpha. You see, we have this twice of sine alpha, cosine alpha. However, it's not exactly the same. You look at this. What is missing? We wish there's a 2, right? But there's this one. I wish it is 2 sine 75 degree, cosine 75 degree. In that case, we will, you see, have this form, double angle formula. But we don't have a 2. So if we do not have the 2, what can we do if I still want to use the formula? So let's put a 2 just for convenience, and you have to divide the 2 because otherwise you cannot put equal sign. So this given expression is half of this, right? If I put a 2. So that is just for convenience, I introduce a 2, but I still have to divide the 2 because the given problem does not have 2. So once you have the two, this is in the form of the formula. So we know that's a double angle formula. So this part can be written as sine of the double angle, which is twice of the 75. Two times the 75 degree. You see, this is the double angle formula for sine when alpha is 75, right? We can compare alpha is 75. So this quantity is just the sine of the double angle. So sine of the double angle of 75. So this part is taken care of, but there's still a half. Then we can continue to get sine of the double angle is 150 degrees. 150 degrees sine 150, okay, we know that 150 has a reference angle, 30. So sine 30 is half. Sine 150 is also half because it's in the second quadrant, still positive. Yeah. So then there's another half. So we see the second half, the one half is the sine value of 150, right? This part. And times half. So final answer is 1/4. So this problem, when we try to solve the third problem, we recognize it's very similar to the double angle formula for sine, but it is not yet. So in order to apply the double angle formula for sine, we need a 2, right? So you multiply a 2 to create a convenience, some convenience for yourself. So this, but you cannot simply change the problem. So that's why we have to divide the 2. We cannot change the given problem. So you can always introduce a 2 and then divide it. So this part allows us to use the double angle identity. So it becomes the sine of double angle of the 75. Then, but still this half is there. So we need to keep the half. So half sine of 150, this becomes a special angle, right? This one, we know the exact value of sine of 150, which is half. So half times half is 1/4. This has a little bit technique. You see, times a constant divide the same constant to create some convenience. Yeah, so we used double angle identities for sine, for cosine, for tangent. And also remember, double angle identities for cosine, we have 3 different versions. Yeah, one version is to involve both sine and cosine, and one version is to involve only sine and or involve only cosine. So we have 3 different versions, right, for the double angle of cosine formula. Okay, you see quite a few applications and hope you know you have memorized these useful formulas.